Good morning. How is the Josh? How is the day? So we'll get started in the interest of time. We have 4 sessions to get covered. So my name is Dineshkumar Singh. I am part of the TCS Research Digital Food Initiative. And I was talking about yesterday, farmers sensor land, just like the Alice Wonderland. So basically, some of the agriculture challenges and opportunities, which are crucial from the research as well as a business perspective. So there is a need for intelligent data monitoring system, which has to be automated and which leads to the resource management in agriculture. So soil is a resource, water is a resource, air is a resource, the seeds which goes into the soil is also a resource. So fundamentally, then whenever there is a resource, there will be a lot of data associated with it. So if we start collecting those data and monitoring those data and then analyzing, that's where insights will get generated. So on one side, when we generate the food, on other side, we generate data and insights. And it includes food such as like fruits and vegetables, cereal, soil, fodder, forest, floriculture, livestock, fisheries, and so on. And the technologies like sensor network, which is wireline and wireless, Internet of the Things, artificial intelligence, big data, UAVs, and so on. And why do we need it? For irrigation, crop optimization, yield prediction, disease detection, and the nutrient management. It looks so easy, but when we pick up a problem and to solve a problem, this is the agriculture sector which has spawned thousands of startups, but still it is not sufficient to address all the problems. Because the value chain and the variety of the crops and the food in that and environmental factors, everything creates a very complex matrix. So when as a researcher, we need to understand that what are we going to do? And we need to think that we have got limited time, limited resources. Limited resources include from the research perspective, limited compute access, limited data access, and also limited domain access. So this is where the complexity of the subject itself leads to the complexity of the research topic. And the challenges, if you look at food security and the sustainable development in the face of the global challenge. Punjab is in the western side of the India is known as the like food bowl of India. And it produces lot of rice and wheat and cotton. If you look at from the data perspective, Punjab is not suitable for the rice. But Punjab is one of the high production area for the rice as well as one of the most export uh, uh, food also from the Punjab. So what is the problem then? The problem is that Punjab, some areas are known as cancer villages. There is a train which goes from some area of Punjab to Delhi, and it's known as cancer train. So it means, is the food for food, or is food for business, or is food for greed? And then the question is how to bring a change. Then there are certain areas of maybe the coastal belt, or we call West Ghata region, which is very naturally populated with different kind of a natural resource. And people are transforming into rice belt. And people are trying to go towards from single crop to the 2 crop per season kind of a thing. What is at the cost? The hills are getting converted into plateau and plateau to the plain land and so on. The question arises that for what? For food or for the greed or for the livelihood? There's a difference between food and the livelihood. Till the time you are hungry, I think maybe some amount of food is good enough. But when your food becomes the business, then probably any big amount of the food is good enough. And that's where the sustainability has become a big, big discussion topic. And people ask, are you working in food sector? And people want to know, are you working in a sustainable food sector? And that is exactly where then the research and the technology can come and play. The research and technology, simple terms can tell, is it suitable reason to grow for a certain kind of a crop or not? Even if certain type of a crops were suitable for a reason, is it still suitable? Example is apples. They require a particular kind of an environment and particular kind of a seasonal effect to ensure the reproductive process. Now, because of the change in the climate, the regions are shifting and then it's affecting the productive process and also the quality and the quantity of the apple. I have worked on the fishery side. There were certain fish species which were found in the Kerala and around southern India part of the whales, known as the local species there, are now found on the near Gujarat. So it means they are also migrating. They are shifting their location or the patterns where to find and kind of. Climate is reality and affecting everything. And that's where we want to know that how and what. And research is required in that. Of course, global conflict, very interesting part. When Ukraine and Russia war started, it affected the entire international supply chain of wheat. And then your traditional uh, parts which used to be the supply hub are affected. Now, the wheat from India, if has to go as a subsidy, there was a new business model. Somebody took it as subsidy, low cost for African nation, and then package, repackage, and transfer to the other part of the location. So we need to really think that how to make that supply chain also robust to is this man-created kind of a conflicts. Energy management, sustainability, again big, the photovoltaic kind of a thing, where grow food and grow energy can happen together. And that's where now there are certain villages where the farms are getting converted into solar farm. And you need to do in a scientific way that it again doesn't become the new plastic of the future. Because when the plastic came, it was considered as a very good invention of the century. And now plastic has become one of the most impact causing invention. So every invention not has to be solving current problem. It has to be studied to be seen what will be the future problem. But agrivoltaic for now is a way to make maybe farming self-sustainable. Automation and robotics, the coordinated use of UOBs and the sensor network. So we need to look at everything from soil, below soil, to the top soil, to on the soil, above soil, how an integrated channel. And then there has to be a coordinated effect. So there are people who have shown many use cases on UOB. They wouldn't stop talking about all the potentiality of the UOB. It's like having a refrigerator, TV, your mobile, everything inside the home, but they are not talking to each other and creating a cumulative effect. How we create a cumulative effect of our integrated sensor technologies of all the time. But of course, in a way that they shouldn't be controlling us, but they should be working with us. So that's another problem and opportunity area. That's where interaction and collaboration. I have met many people who started talking agriculture jargon. And that's the challenge. It's like somebody working as assistant to doctor decided to become a surgeon. We don't want to change agriculture scientist into an IT person, an IT scientist into agriculture. Everybody is skilled and talent based on their own interest, passion, and the experience. That is where interaction and collaboration become very important. Aerial mapping, crop management. Aerial mapping, again, a very interesting and important area. Managing UAV data, mosaicing, aligning, geocoding, georeferencing. And not only that, but how to make it in alignment with that of the data from the aeroplane-based data or the satellite data or maybe that of the ground rovers and so on. And that's become an interesting research topic. Better data analysis, monitoring, resource allocation, optimization. If you look at in general, resource allocation looks so simple. But take a context of a village. A village has got different area which is geographically divided, politically divided, socially divided, class-wise divided, so many of division, and then fight for the resource. So if there is a less rain and if there is groundwater dependency, now who should get the how much water? So can the technology become that transparent mirror to bring that kind of a resource allocation? Security threat, blockchain technology, software defined networking, and so on. I have seen the situations where the entire supply chain of a meat in Australia 3 years back was disrupted for 4 days. The lines of the trucks with all the meats were on the road, creating a 12-kilometer of a chain. The meats were of no use to anybody. And what was that? Because the network, people forgot that one app which connects to the supply and chain ease of use become the reason for the attack. So ransomware, they were not paid, and that's how this issue started. So we need to think that your IoT with a default password may become a reason for attack. So security has to be now taken that seriously on that level. And of course, emerging area, urban farming, distributed farming, and farming as a utility are fast. Farming as a service, where this different kind of innovative business models may come. Farming as a utility in the sense that the produce which can be delivered based on your choices, the tractors as a service, and so on. So crux is that if this slide, if you look at, it kind of triggered multiple thoughts for what kind of a problems available, what kind of a technology research available, what kind of a operational research available, and of course, what kind of a business and market research available. We as a student of this, we need to pick and choose one and go deeper. And we need to collaborate with others who are strong in their field to have something sustainable. If the objective is to create something, create for an award, create for a publication, create for a research, public a paper patent, anything is better. But then time and money is not unlimited. When we have to do something, we have to think through that, how the investment gets returned, and the return on the society, return on the business, and return also on the environment. So if you look at this is the crux and a kind of a done for my topic today. I'm not going in each and every slide which I covered. I found this is interesting where it shows that how if we pick up one particular problem area, it goes from bottom to the top, taking through the pointers which I was talking about. What I'm going to acquire, what is the mean to acquire, how I'm going to store it, how I'm going to integrate it, how I'm going to analyze it, and what I'm going to eventually do with it. So keeping the end user, the customer in mind, this is how the entire journey starts. So when somebody talks to me and says that there is a use case, I'm just trying to understand where is that use case at what point. Is the clarity and the depth there, or is it just person want to speak and I should just respect and listen? But if there is a serious work and serious investment of our time, I think we should go deeper. This can be handled. And some of the other things which I said as a problem and opportunity are many. The work on the network architecture, work on the data. A lot of opportunities are possible on the data itself. Big data, then the prediction and the learning approaches. We need to think that what actually you are predicting and for whom. Is it for farmer? Will the farmer pay for that? So that value has to come somehow as another parameter in the prediction. And then, of course, security and privacy. You have to, or we have to think not as a local player, we need to think a global village. And that's where our horizon increases if we think end to end. Because what works here may not be accepted in some other geography. So this is just another example of that bottom-up approach, how we have to go deeper and then start with the libraries, and in a way that the libraries at the lower level help achieve the higher level solutions. With that, I will end. Thank you very much.